Hi everyone, I'm going to talk about post-combustion capture of carbon capture and storage, and I will focus about how to reduce the cost of post-combustion capture. And carbon capture and storage, so-called CCS, is the process of capturing waste carbon dioxide usually from large point sources, such as power plants or a cement factory, transporting it to a storage site and depositing it where it will not enter the atmosphere, normally underground geological formation. As we know, global warming caused by greenhouse gases generated by the combustion of fossil fuels has become a major challenge of human beings nowadays. And this will lead to the deterioration of the ecological environment and bring disastrous consequences to mankind. And among the greenhouse gases emitted, carbon dioxide accounts for about 65% of the total greenhouse gases. And Intergovernmental Panel on Climate Change believe that CCS plays an important role on curbing global warming. And this is the reason why CCS is so important. In applying CCS technology, modern conventional power plants can reduce carbon dioxide emissions by approximately 80 to 90%. However, collecting and compressing carbon dioxide may increase the energy requirements of a coal-fired CCS power plant by around 25 to 40%. And the cost of other system may increase the power plant's cost per watt of energy by 21 to 91%. It will be more expensive to apply this technology to existing power plants. And post-combustion capture, which carbon dioxide is removed after combustion of fossil fuels, is most popular for carbon dioxide capture on industrial gases because existing fossil fuels power plants can be retrofitted to include the CCS technology in this configuration. And therefore, how to reduce the cost would be the key question. And fortunately, the DMX process developed at IFP Energy's novels based on special solvents which are characterized by the formation of two immiscible phases for given temperature and carbon dioxide loading conditions might be an answer. In the case that using 30% weight MEA process to meet the requirements of 90% recovery of carbon dioxide from the flue gas while delivering a high purity carbon dioxide to storage, about 3.7 gigajoule per ton carbon dioxide are required for solvent regeneration. And thus energy penalty is the main driver that MEA-based post-capture combustion capture process requires a high energy consumption. And amines are commonly used for chemical absorption of basic gas such as carbon dioxide post-combustion capture, but ethanolamine are preferred for several reasons. Firstly, as a functional group, alcohol group can reduce the vapor pressure of the amine, which can guarantee no contamination of the treated gas by the amine. Secondly, it can also tune the basicity of the amine, thus reaction more easily to happen. And finally, increase the solubility of the amine in water and keeps the dielectric constant of the solvent high, even at high amine concentration. And high amine solubility and the high dielectric constant are two important features in order to avoid any liquid-liquid phase separation or precipitation. However, if we regard liquid-liquid phase separation as an opportunity instead of a drawback, it might be a way to reduce the cost of carbon dioxide capture. In the DMX process, after the heat cross-exchanger between the absorber and the stripper, we can obtain a water-rich phase with a high carbon dioxide loading and a amine-rich phase with a very low carbon dioxide loading. Thus, the last phase does not need to go through the stripper and as its loading is very low. Therefore, the separation of the phases allows us to reduce the liquid flow rate in the stripper, and thus the energy requirements for the generation of the solvent will be decreased. Comparing to water MEA carbon dioxide system, DMX process, which uses so-called DMX1 solvent, shows high cyclic capacity, low stripping energy, low heat of absorption, and only a proportion of the fluids towards the regeneration step, which can expect important energy savings. And the process simulation shows that a significant decrease in energy consumption from 3.7 gigajoule per ton carbon dioxide to 2.3 gigajoule per ton carbon dioxide, comparing with 30% weight MEA process, which reached the goal of reducing cost. And besides, the experiment data shows it takes the advantages of low degradation, low corrosion, and fast separation. And these will build the confidence for industrial design. That's it. Thank you.